Hello everyone. Today we're going to be looking at section 2-3, which is product and quotient rules and higher order derivatives. In our previous lectures, we talked about finding derivatives of functions using different rules such as constant, power, sum and difference rules. And then we also found out the derivatives of sine and cosine functions. You apply the application of derivatives of functions, rate of change. And in this lecture, I'm going to be talking more about the product and the quotient rules and derivatives of trigonometric and higher order derivatives. Specifically, today's lecture, I will be looking at product rule. So what's a product rule? Product rule simply means when you have functions which are multiplied to each other, say y equals fx times gx, for example, x squared times sine x. So we like to differentiate these kind of functions. Now the natural way is, okay, take the differential of say 2x, take the differential of sine x, you multiply. But the question is this right? Is this the correct approach? So what I'm going to do is, I'm going to take a very simple experiment and then show to you what actually is a product rule. Now consider this function. It's a function 4x squared plus x times 3x minus 5. So we have a squaring function with a linear function. This function can be easily simplified, but at this point just apply the normal procedure we taught as earlier. So if I want to take the derivative of these two functions, I'll take the derivative of the first and take the derivative of the second and multiply. So what we get is 8x plus 1 times 3, and the final answer is 24x plus 3. Okay, that was just a natural instinct of saying, hey, that's how things are. But now let's actually really simplify this, the function which is given, and then differentiate. Okay, so y equals 4x squared plus x times 3x minus 5. When you do the math, you get 12x cubed minus 17x squared minus 5x. Okay, so this is the original function when we literally simplified it. And when we differentiated this equation too, we get 36x squared minus 34x minus 5. Notice, this was our natural instinct, like the way we're normally learning, but when we literally simplified it, we got this expression. Clearly, equation 1 and equation 3 are not correct, are not the same. So that tells us that the product rule by which we were just, applying the things we have learned is not the right one. Okay, that is what the next slide actually talks about. So the conclusion is that we're getting two different answers, one from what we just thought about and what we actually got after doing our, simplification and differentials. So there is a little difference here. Now let's look at the real definition of a product rule. Now the product of two differentiable functions fx and gx is also differentiable, and it is given like this. The differential ddx of fx times gx is the differential of the first f prime of x times the second function. So think of this first times the second. So differential of the first function times the second function plus the first function times the differential of the second. So let's go back to this original problem we started with, and let's apply the real product rule. So we have 4x squared plus x times 3x minus 5. So normally what I do is I write 1 and 2 beneath it, so make my life simple. And then I'm going to take the differential of the first, which is written as 4x squared plus x, the prime, that's basically meaning I'm taking differential, times the second function, 3x minus 5, plus. Then I keep the first function as it is, 4x squared plus x, and take the differential of the second. That's 3x minus 5. Now let's take the differential of the first function. in this expression 4x squared plus x, which is 8x plus 1 times 3x minus 5, plus in the second expression we had here, we're going to take the differential of the second term, which is 3x minus 5, which gives us 3. And we're going to multiply this to the first function 4x squared plus x. Let's go ahead, open this up. Simple algebra we're doing. So we get 24x squared minus 40x plus 3x minus 5 plus 12x squared plus 3x. And then we just, gather the like terms, and what we get is 36x squared minus 34x minus 5. Notice this expression is exactly the same as what we had done when we simplified and differentiated. So that product rule which we have used is the correct rule for us. Okay, so this is not only valid for two functions, guys. You can have as many finite numbers, say 3, 4, but the rule is you take a differential of no matter like how many functions you are multiplying, one at a time, and the rest of the functions remain there. So in the next slide, I'm talking about that. That is, I'm just increasing the number of functions. Instead of 2, we have 3. So if I take the differential of f times g times h, it's basically the differential of f with g times h plus the first function times the differential of the second function times the third function, which is x. Remember, 1, 2, 3. Then plus again, first function, second function times the differential of the third function. Okay, let's take an example. And I'm going to have some trig involved here. Y equals x squared times sine x times cosine x. So according to the rule of product, what are we going to take when we take the differential of this function? We are first going to do is write beneath. What I normally do is I write 1, 2, 3. Now when I take the differential, I'll take the differential of the first x squared, and the next two functions sine and cosine, they remain like that, and they're multiplied to the whole expression here. Then you have a plus. Now the x squared and cosine x remain the same. You're taking the differential of the second function, which is sine x. Then again another plus. You keep the first two functions as it is. That means x squared times sine x. Then multiply with the differential of the third function, which is cosine. And after that, you just go ahead, do the differentials, and then do algebra. So the first one, in the first expression, we get 2x times sine x cosine x. The second one gives us plus x squared times cosine x plus x squared times sine x minus sine x. Remember, differential of cosine is minus. Then I'm just going to write it in a more, concise notation. So the first expression, 2x times sine x times cosine x, remains the same. Now remember, it's cosine x times cosine x. Notice this one we're doing. Cosine x times cosine x. So it's basically cosine x squared. No? It's like 2 times 2. So basically you're multiplying the same expression twice. Now to write it, another way of writing this is cosine square x. So basically when I say cosine square x, I'm saying cosine x multiplied with itself. Similarly, the last expression, x squared times sine x times minus sine x, is basically minus x squared times sine square x. So we can do one more little algebra here. The last two expressions have an x squared common. I take that x squared out and write this as cosine square x minus sine square x plus 2x times sine x cosine x. Now if you want to do a little bit more trick here, you can go ahead. Otherwise, this is fine as an answer. Okay. Now let's do some examples of the product rule. So we're going to differentiate the function. The first one is y equals 1 minus x squared plus 2x cubed times 5 sine x. So it's two functions. The first function is a cubic function. The second is a trig function. So according to the definition of product rule, we're going to take the differential of the first function, which is 1 minus x squared plus 2x cubed. Then times the second function as it is, which is 5 sine x, then plus, keep the first expression as it is, which is 1 minus x squared plus 2x cubed, and take the differential of the second, which is 5 sine x differential. After that, you just simply do the differentials. Then minus 2x plus 6x squared times 5 sine x, plus then 1 minus x squared plus 2x cubed times 5 cosine x. And you can leave it as it is. You know, even if you do a little algebra, it's not going to give us much. You know, you can't add like terms because you're having the sines and the cosines. Or even if you want to do a little bit, you can do it. You know, gather x squared terms together, but there are going to be some sines and cosines. If you're doing in the exam, just leave it like this. That's good enough for full credit. Okay, now let's look at another one. Differentiate this function. Now there are two expressions, and one of the expressions is a product of two functions. So y equals 6x plus 5 times x squared minus 2. So this is one function, which is product of two functions, and the second function also is a product of two functions, square root x times x cubed minus 1. But both these two functions are joined by an addition. So what you're basically going to do is, when you take the differential, the first thing we're going to do apply is we're going to take the differential of this expression plus the differential of this expression. I just kind of saved space. So your y prime, so what I've done is the first expression is this. So what is going to happen is y prime is this, 6x plus 5 x squared minus 2. This is the, because first you apply the sum and the difference rule, remember, plus square root of x times x cubed minus 1. So first the sum rule. Now you go integrally and apply the differentials, and that's where the next step comes here, which I've written here, is 6x plus 5 differential times x squared minus 2 plus the first expression 6x plus 5 times x squared minus 2 differential. Notice, when I start the product rule, I make my life simple, right? Oh, this is the first expression, this is the second expression or function, what you want to say here. Now, in the second, in the sum rule, we have a square root x times x cubed minus 1. So square root x is my first function, x cubed minus 1 is second function. And when I write it down, you're taking the differential of square root x times x cubed minus 1. Then again a plus square root x times differential of x cubed minus 1. After that, you just do the differentials. You're getting the expression in the second line here, 6 times x squared minus 2 plus 6x plus 5 times 2x plus differential of square root of x is half of x to the power minus half times x cubed minus 1 plus square root of x times 3x squared. And then I'm just going to do a little bit more algebra, because the first two expressions in this line can easily be gathered together and have some like terms. So what we get is 6x squared minus 12 plus 12x squared plus 10x. The second one, I'm just writing it in much more nicer looking form, 1 over 2x half, x cubed minus 1, and this other one is root x times 3 times x squared. Then in the last line, what I've done is I have gathered from the first four terms in this expression, x squared together, we get 18x squared minus 12 plus 10x. And then what I've done is, instead of writing 2x to the power half, I'm writing it in the proper radical root form, 1 over 2 square root of x, x cubed minus 1. And then what I've done over here, the last expression is basically, remember, x times x squared. You can apply the exponent properties. This is x to the power half times x squared, which is x to the power, you can add half plus 2, which is basically 5 halves. So it's 3x to the power 5 halves. Okay, so let's do one more example of product rule and see how we can apply a little bit more techniques here. So this question says, find the derivative of the function y equals 3x to the power 6 minus x to the power 5 divided by x4 at a point c equals minus 1. So you're taking the derivative and you're finding the derivative at a point, specific point. What basically it means is you first take the normal differentials as we have learned, and then evaluate that differential at the point minus 1. That's what basically it is asking. So the first thing we're going to do is, because remember this, we only know the rules we have learned is constant, power, then sum and difference, and the constant multiple, and now we have learned is a product rule. We have not yet learned a rule where we have expressions one over the one term over the other. So, but when we look at this expression, and if you had recollect things which I did in the basic differential rules, if you have an expression where there's only one term in the denominator, then you can actually take every individual term in the numerator and divide by that one term. So that's what I'm doing. And that makes it more simple because easily I can apply it then. Once I've done my little techniques over here of algebra, I am able to get an expression which is more easy for me. So let's do that. So fx is 3x6 minus x5 over x4. I can write this as 3x6 over x4 minus x5 over x4 and apply little exponents rules. We get 3x squared minus x. Now this is much more easy to work with. So if I take the differential of this function, I get 6x minus 1. And the question says, find the value of the derivative of this function at the point c equals minus 1. So what's the final answer? So f prime at minus 1 is 6 times minus 1, which is minus 7. So guys, it's time for you to practice. I've given you around 8 problems. My recommendation is practice these problems. Very important. Thank you.